This example goes with section 4.5, graphs of sine and cosine functions. This is the harmonic motion problem. Example 6. A mechanical metronome uses an inverted pendulum that makes a regular rhythmic click as it swings to the left and right. With each swing, the pendulum moves 3 inches to the left and right of center position. The pendulum is initially pulled to the right 3 inches and then released. It returns to its starting position in 0.8 seconds. Assuming that this pattern continues indefinitely and behaves like a cosine wave, write a function of the form x of t is equal to a times the cosine of the quantity bt minus c plus d. The value x of t is the horizontal position in inches relative to the center line of the pendulum. Alright, so let's look at this piece by piece. And I'm just going to rewrite my formula back here. X of t is equal to a times the cosine of b times t minus c plus d. Alright, remember a stands for the amplitude. And this is defined to be half of the absolute value of the maximum minus the minimum. Okay, now remember our metronome kind of looks like this right here, where you have the little arrow thing sticking straight up like this, and then you can pull it this direction and then it moves just like this, click, 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 until you stop it, okay, with, you know, the little triangle here being the base. Or if you wanted to, you could pull it this way, but the same effect happens. It's just going to move back and forth, and make a clicking sound every time it stops. Click, 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 and so on and so on, okay? So since we know that when we start this, we are pulling the pendulum 3 inches to the left. Actually, it moves 3 inches to the left and to the right. And so what that means for our picture is over here, we're going to move -3 to the left of center, and over here we'll be moving +3 to the right of center. In other words, this will be my min, and this will be my max. So the amplitude for this problem is going to be 1/2 of 3 minus -3, which is going to be 1/2 of 6, the absolute value of 6, which is going to give me 3. So the amplitude on our equation is going to be 3. So we have x of t is equal to 3 times the cosine. Let's see. The pendulum is initially pulled to the right. That's important, because what that tells me is that we're going to use a +3 right here instead of the -3. If it had been pulled initially to the left toward my minimum value, then we would have had a -3 in here. Okay, now, thinking way back to section 4.5 when we started graphing the sines and the cosines, the b number right here, this helped us to find the period. The period was defined to be 2 pi divided by b. Well, b is what we're looking for. The period we happen to know because it tells me right here the period is 0.8 seconds. So we can use this information to figure out what b is. If we set 0.8 equal to 2 pi divided by b. Now I can treat this as a proportion, and I can cross multiply, and that's going to give me 0.8 times b equal to 2 pi, and then if I'm solving for b, I'm going to divide out that 0.8, and b is going to be equal to 5 pi over 2. So now we've got 5 pi over 2 times t. All right, c, this is the phase shift. This is our left and right movement, okay? So the entire graph, whether it's going to be picked up and moved to the left and the right, well, let's look at this. Here's the base. Here's the center of the base. And at no point in time is this metronome going to pick up and move off in this direction, or is it going to pick up and move off in this direction? It's going to stay centered here, and the only part of it that's going to move is going to be the arrow portion of it right here. And so what that tells me is, in our case right here, there will be a phase shift of 0, or no phase shift if you want to call it that. Okay? D right here, this is the vertical shift. Now again, we go back here and we look at the metronome. Again, here's the base, here's the center. And once we get this thing going, at no point in time is this whole thing going to pick up and move up. And at no point in time is this whole thing going to pick up and move down. And what that tells me is that in this particular case, we're not going to have any kind of a vertical shift either. And so that means that my equation to describe the movement of the metronome, or of the arrow part of the metronome, is right here. X of t is equal to 3 times the cosine of 5 pi over 2 times t.